Hi class, today I'm going to go over the second law practice quiz. I've already gone ahead and drawn in the force diagrams just to make this a little bit quicker on me. Number one says, which of the following has a net force on it? What you guys need to know is that if there is a net force by Newton's second law, there is an acceleration. Okay, so you're just looking for objects that are accelerating, which are objects changing speeds. So in that case, it is A and it is D. The other two objects are at rest or at a constant speed, which means there is not a net force on the object. Number 2 and 3 basically show a person pulling up with a rope, Ft, on a block that is being pulled down by gravity. And it's saying if you were pulling at a constant speed, how would the tension force change if you were just initially holding it at rest? Well, what you should know is if you're pulling at a constant speed, the acceleration is 0. And if the acceleration is 0, there is no net force. That means the forces up and down are the same, which would mean it is answer choice C. Now, if you're just holding that object still and then you accelerate it upwards, well, in that case, the acceleration is up. And if the acceleration is up, it means there is more force upwards than downwards, which means the tension force, which is up, is going to become greater. All right, number 4 says I'm pushing a physics cart in class, and I want to determine several things. The first thing is drawing a force diagram, and you can see that below. We've got normal force up, gravity down, applied force to the right, and friction force to the left. When I want to do part B, it says solve for the acceleration using one of the equations on the top of the sheet. Well, going through the problem, I can see that it accelerates from rest, so that's my initial velocity. It gets to a velocity of 3 meters per second while going a distance delta x of 0.9 meters. And I want to solve for the acceleration. That means I have to find an equation that has those 4 things in it, and I already know it, which is Vf squared equals V naught squared plus 2a delta x. So my final velocity is 3 squared equals 0 squared plus 2 times a times 0.9. And I can use my algebra, and what I would do is I would do 3 squared, which is 9, and then I would divide that by the other side, and I would do 2 times 0.9, so that would be 1.8, and I would divide both sides by 1.8. And I get an acceleration of 5 meters per second squared. I then want to calculate out the applied force, and whenever we're doing that, we're going to be using F net equals ma. And you can look at our force diagram, and this object is accelerating to the right. So that means the forces going to the right are going to be positive, and the forces going to the left are going to be negative, and the forces up and down are going to cancel out. Therefore, when I do my F net equals ma, I have a positive Fa, and I subtract off the Ff, and that's going to equal mass times acceleration. So my applied force, I don't know. My friction force is in the problem, it's half a Newton. My mass is in the problem, it's a little hidden. It's a 0.25 kilogram car with 4 0.25 kilogram weights. So if I add those all up, I get a mass of 1.25 kilograms, and my acceleration from part B was 5. So to get my answer, I would do 5 times 1.25, and then I would add 0.5. And you get an applied force of 6.75 newtons. Number 5. This is a person sliding to a stop in a baseball game. We know the friction force on the player. We want to calculate out the acceleration of the baseball player. Well, I drew the force diagram. There's Fn up, Fg down, and friction force to the left. He's not pushing himself. He's just sliding to a stop. That's why there's no applied force, and that's probably the most important part of this problem. So when you do F net equals ma, we should know that this player is moving to the right, okay? Now we can define left and right as positive or negative. I'm going to go ahead and just say to the left is positive. So I'm just going to make this friction force positive. And m times a, because the Fn and the Fg cancel out. There's no movement up or down. So I just have positive Ff equals ma. And if I know the friction force is 500, and I know the mass of the player is 70, I can solve for the acceleration. And that's 7.14 meters per second squared. Now, you might be asking yourself, isn't this person slowing down? Shouldn't the answer be negative? And the answer is, yeah. What you could do, and a lot of people will do, is they're going to say, I'm going to say, the acceleration, I should say, the forces to the left are going to be negative, which is fine, so I can make this negative. And any force to the right, which there are none, would be positive, so this would be negative, and that would make my answer negative there. So it's very possible. It all depends on how you define which way positive and negative are. All right, now we have another object being lifted straight up with a rope, and I've got my force diagram, which is Ft up and Fg down, and we want to figure out the tension in the rope. So just like all problems, we'll start off with F net equals ma. We know the object is accelerating upward, so I'm going to say up is a positive acceleration. So that means that the ones going up, I'm going to make positive, and the forces going the opposite way are going to be negative. So I'm going to say positive Ft, subtract off, because it's negative, the Fg, equals m times a. And I'm going to do Ft, and the formula for Fg is mass, which in this case is 40, times 9.8, and that's going to equal our mass times the acceleration in the problem, which is 3. And then our tension force would just be 40 times 3, and then I would add in the 40 times 9.8, which is 512 newtons. Last problem. This is a person pushing an object with 300 newtons of force, so I'll actually go label that in. And it speeds up according to the graph below. Determine the friction force on the object. So this object's going to accelerate to the right. So what that means is I'm going to make everything going to the right positive. Anything going to the left, which would be friction force, I'll make that negative. And because there's no acceleration up or down, Fn and Fg will once again cancel each other out. So when I do F net equals ma, I make my applied force positive, my friction force negative, so I subtract that off, equals m times a. And then I can start filling in what I know. So in the problem it says the applied force is 300 newtons, the friction force we don't know, my mass is 40 kilograms, my acceleration comes off the graph. And the key thing here is that you should know that the slope of a velocity graph is your acceleration. So in this problem, the slope is 12 over 4, which is equal to 3 meters per second squared. So my acceleration is 3. And then just make sure that you algebraically do this correct. I'm going to subtract off 300 from both sides. So if I have 120 on the right side and I subtract off 300, I'm going to get negative 180. But I still have this minus FF on the left side. So this is still technically minus FF equals minus 180, and FF equals positive 180 newtons. Although, depending on how you set up your problem, it is possible you could end up with a negative 180 newtons for friction, and you would also be correct. Okay, I think that is it. Hopefully this all made sense and went very well. I'll see you guys soon.